Hello, my name is Mohammed. I am mathematics teacher in Nazarbayev Intellectual School of Almaty. We will start our lesson with a simple problem on addition. Find the sum of what you see on the screen. 1 plus 3 plus 5 plus 7 plus 9. Your answer is 25, right? Awesome. We just found the sum of small arithmetic series. It only had 5 terms. But what if we had 1 million terms? We would want a formula for that. The topic of our today's lesson is sum of the first n terms of arithmetic progression. And the goals of the lesson are to be able to prove the formula of the sum of the first n terms of arithmetic progression and to apply the formula of the sum of the first n terms of arithmetic progression in simple cases. Now you will see a short video from the site hanacademy.org on the simple case of arithmetic progression. The simplest arithmetic progression what you can imagine is 1, 2, 3 and so on, and how to find the sum of the first n terms.
Let's say we have the simplest of arithmetic sequences and probably the simplest of sequences. So 1, 2, we're going to start at 1 and just increment by 1. 1, 2, 3, and we're going to go all the way to n. And what I want to think about is what is the sum of this sequence going to be? And the sum of a sequence, we already know, we call a series. So what is the sum, and I'll just call it S sub n, what is this going to be equal to? 1 plus 2 plus 3 plus going all the way to n. Well, we're going to do a neat little trick here where I'm going to rewrite this sum. So I'll write it again as S sub n. But now I'm just going to write it in reverse order. I'm going to write it as n plus n minus 1 plus n minus 2 all the way to 1. And now I'm going to add these two equations. So we know that S sub n is equal to this, so we're adding the same thing to both sides of this equation up here. So on the left-hand side, you're going to have S sub n plus S sub n is just 2 times S sub n. And on the right-hand side, and this is where we start to see something kind of cool, you have a 1 plus an n, which is just going to be n plus 1. You have a 2 plus n minus 1, which is, well, 2 plus n minus 1 is going to be n plus 1 again, plus n plus 1. You have a 3 plus n minus 2. Well, that's going to be n plus 1 again. N plus 1. I think you see what is going on here. And you're going to go all the way to this last pair, I guess you could say it, or call it these last two terms. And we have an n plus 1 again, plus n plus 1. So how many of these n plus 1s do we have? Well, we have n of them. There were n of these terms in each of these equations. 1, 2, 3, all the way to n. So we can rewrite this thing as 2 times S sub n is equal to, you have n plus 1 terms. So we could write it as n times n plus 1. N times n plus 1. And now, to solve for S sub n, to solve for our sum, we can just divide both sides. We can just divide both sides by 2. And so we are going to be left with the sum from 1 to n, this arithmetic sequence where we're just incrementing by 1, starting at 1, is going to be equal to n times n plus 1 over 2. And this is neat because now you can quickly find the sum, let's say from 1 to 100. It'll be 100 times 101 over 2. So very quickly you can find these sums. And what I'm curious about and what we'll explore in the next video is, can we generalize this for any arithmetic sequence? We started with a very simple one. We started at 1, we just incremented by 1. And it looks like this is, so if I were to write it this way, this is n times n plus 1 over 2. So this right over here, this n, this is the nth term in our sequence. And this right over here, this 1, was the first term in our sequence. So at least in this case, it looks like I took the average of the first term and the nth term. So this right over here, let me make it clear. This is the average. Actually, we do it like this. This right over here is the average of a sub 1 and a sub n, and then I'm multiplying that times n. And what I'm curious about is whether this is going to be true for any arithmetic sequence, that the sum of it is going to be the average of the first and the last term times the number of terms.
We'll start with a problem, text problem. Seni would like to give a sum of money to a charity each year for 10 years. She decides to give $100 in the first year and to increase her contribution by $20 each year. How much does she give in the last year? And how much does the charity receive from her altogether? Well, the answer for the first problem is easier, and you probably know the answer for that. How much does she give in the last year? Also, she makes 10 contributions. There are only 9 increases, 9 steps. So in the last year, she gives 100 plus 9 times 20, and 20 is the step, the common difference of arithmetic sequence. And it will be $280 on the 10th year. Now, to answer the second question, how much does the charity receive from her altogether? We can just write the sum. The total amount the charity receives in dollars is S, then S is equal to 100 plus 120 plus 140 and so on, up to $280. How can we find the sum? With only 10 numbers, it is easy enough to add this up. But you can also find the sum by a method which is similar to that we used to find the formula in the video. If you add up these numbers in reverse order, you'll get this. The same numbers but in reverse order. And previously we had that. So what we can see here, what can you notice here? Adding up those two equations gives us 2s is equal 380 plus 380 and so on, 380 in the end. That is because each pair in the right side, on the right side of each equation gives 380 in total. So 380 occurs 10 times. So 2s is equal to $3,800, giving us that s is $1,900. So over the 10 years, charity receives $1,900. We can see the same solution on the diagram. Here, by crosses, you can see the sums, like 5 crosses on the top of the trapezoid is $100. The next 6 crosses is $120, and so on up to $280 on the last line. When we wrote the same in the reverse order, we received that diagram. You see here the notes and $280 in notes on the first line, and we add that number to $100. And since number of crosses increases and number of notes decreases, the total sum is always 380, and we have 10 times that sum. Here's first formula for s, and here's a formula for 2s when we add those two expressions. So the s, the total amount the charity received, is 100, which was the first line, the first sum Seni gave to the charity, plus the sum she gave on the last month, all together multiplied by number of months, and then divided by 2, because before that it was just two sums. You can notice that the formula is similar to formula of area of trapezoid. You can see the trapezoid on left side of the screen. Two bases of trapezoids are 100 and 280, and the height of trapezoid is 10 because it was 10 months. The formula of area of trapezoid, as you can remember, is as follows. Area of trapezoid is 1/2 of the sum of its bases and multiplied by the height. So basically you already knew the formula, but in different context. And now you know the formula for the sum of the first n terms of arithmetic sequence. Let's check how you know it. Identify the formula for the sum of an arithmetic series. Is it on the top or on the bottom? Yes, it's on the bottom, because you add the first and the last term of arithmetic sequence, not multiply them. And now try to apply that formula in the case you already know the answer. 1 plus 3 plus 5 plus 7 plus 9. Choose the answer that shows the formula correctly used to find the sum. First, second, third, or the fourth formula? Yeah, it's the fourth formula, because you add the first and the last terms divided by 2 and multiply by the number of terms. You see there were 5 terms. 1 is the first, 3 is the second, and so on, 9 is the fifth. Alright, so we are feeling good so far. Let's try to use the formula to find the sum of an arithmetic series. That would be tedious to calculate by hand. Consider the series here. 3 plus 5 plus 7 plus so on up to 401. Can you calculate it? Okay, we know the formula. First we need to find the first and the last term of the series. What are they? Write them down. Yeah, there are 3 and 401.